So number 3, a woman planning for retirement wants to have an account that will pay $25,000 semi-annually at the end of each period for 6 years. How much does she need in the account when she retires for this to be possible? And if she can invest 6% compounded annually, how much does she need to invest at the end of each 6-month period for the next 30 years in order to begin drawing $25,000 from the account in June of the 31st year? And so this is an example of a retirement situation. And so when we're figuring out how to set someone up to be able to have a certain amount of money coming to them in retirement, we need to work backwards and start in retirement and then go to what we need to be putting away now to make that happen. And so we are going to be starting with present value of an annuity because we want the account to pay out $25,000 a year to this woman. So we've got our SERMTN going on here. And so we want $25,000 twice a year to be coming out of the account. And the rate is 6%. And so we're going to assume that the rate is the same for the retirement years as it is for the time that she's investing. And she wants that to happen for 6 years. So R over M is 0.06 over 2, which is going to be 0.03. And then MT is going to be 2 times 6, which is going to give us 12. And so present value of ordinary annuity is what this is going to be. So we've got S equals R times 1 plus, no, got to look at my formulas real quick. 1 minus, yeah. So 1 minus 1 plus I to the power of negative N over I. I can never memorize these things. So, which would be, it would be crazy to try and memorize these darn things. So, what we've got is S equals 25,000 times 1 minus 1 plus 0.03 to the power of negative 12 over 0.03. And so I'm going to go over to my other deal here and copy my present value of annuity formula. We'll slap that into Wolfram. And I is 0.03. And is 12.03. So this is going to tell us how much money she needs to have in the account when she gets to retirement in order to do what she wants to do. And so we've got S is equal to $248,850.10. So she needs $248,850.10 in the account when she retires. So that's the amount that she's going to need in the account when she retires to have to be able to take $25,000 out every 6 months for 6 years. And so moving on, we need to now tell her what she needs to do in order to reach that amount in the account. And so she's going to invest. She's going to put money in the account semi-annually, and she's going to do that for 30 years. And so let's take a look at, now we have a future value of ordinary annuity. We are trying to get money in an account and make it grow. So we want to reach a value of $248,850.10. We don't know what her semi-annual payment is going to need to be able to achieve that. and it is 6% interest, so 0.06. Twice a year, she's going to put money in the account. She's going to do that for 30 years. Is that correct? Yep, 30 years. So our R over M is 0.06 over 2, so 0.03. And our MT is going to be 2 times 30, so 60. And so this is, again, a future value of ordinary annuity. So we are going to have S equals R times 1 plus I to the power of N minus 1 over I. And got to go grab my formula so I can throw it at Wolfram here. Okay. And so we will have, I'm just making sure I wrote my formula correctly. Not easy to memorize these darn things. So that's actually not correct. Schlegel, you want the S over there on the left, 248, 850, and 10 cents equals R times 1 plus I is 0.03. The power of N is 60 minus 1 over 0.03. And so got our value 248,850.10. Don't know what the payment's going to be. I is 0.03. N is 60. And I is 0.03. Got to divide by, it's a weird one. I'm going to pause this for one moment. And that's why. That says 3, not 0.03. Forgot my decimal. That was kind of strange. All right, so I got to divide by 163,053. Oops, and that's a 3, Schlegel, not a 2. Couple typos on this one. So she needs to put away $1,526.19 every 6 months. To reach her goal. So she needs to invest $1,526.19 every 6 months for 30 years to reach her goal. And so that's going to be it for number 3. Hopefully this is helpful.